And we need to share. You'll have to start the presentation from the beginning. So our second speaker of the day is also a graduate student in my lab, and that is Iradukunda. Mark is originally from Rwanda, and he came to the US almost 5 years ago now. And he went to the University of Nebraska to get his undergraduate degree there. When he was at the University of Nebraska, he worked on hydroponics. He got involved with the American Society for Horticultural Science, and he signed up for a mentorship program through ASHS. And guess who his random mentor happened to be? I think you all guessed right. And guess what topic he wanted mentorship on? How to get into graduate school. And funny enough, he had already talked to a former graduate student of mine who told him, whatever you do, do go to Georgia if you can. And so we started talking about graduate school. I tried very hard to talk him into going elsewhere. No luck, he is here, and he is doing a lot of imaging work, and specifically looking at how we can use different imaging techniques to quantify the quality of seeds and seedlings. With that, Mark, all yours.
I want to get rid of the top of it. I don't know if we can go with
and then you can hide floating meeting controls.
Hi everyone, my name is Mark, and
That's my name.
okay, yeah, and the first topic is my last name. My last name is Iradukunda. Perfect. Now the next topic. I am working on different image systems to quantify germination rate and seedling vigor in different cultivars. So yeah, let's start with a few definitions. So in our study, when we talk about seed vigor, we're looking at the seed's ability to germinate to a viable seedling. And we're looking for qualities in terms of germination rate, the uniformity of germination, and the speed of germination. And when we talk about seedling, specifically we're talking about a young plant that can perform photosynthesis. And the vigor, we're looking at the size of the seedling, the health, and the growth rate of the seedling. So to move from a seed to a seedling, germination has to happen. And when we talk about germination, we're looking at when the seed resumes its metabolic activities. And in the early stage of germination, it's a reversible process, and that's how they do priming, but we're not going into that. And so there are environmental influences to germination, and environment can act in two ways. First, as a signal to tell the seed, hey, this is a good time. And then another way to also influence how successful and how good this seed germination will happen. But we work in controlled environments, we can control that. So we are interested in looking at the seed factors. And so in germination, it starts at the maturity stage, and that's because the seed has to store metabolites, and those metabolites will be used during the germination, and their quality will determine the vigor. And so that's why we say seed germination quality starts at maturation, seed maturation. And this is maturation, when we're moving into seed dormancy, we talk about hormonal balance. So we have gibberellic acid being more, so we have dormancy. But if you want to transition into germination, the balance shifts to favor more gibberellic acid, and there are other many factors, of course, and that's how we transition into germination. And we will have our seedling, and that's what we are interested in. So what can we do with all that? So first of all, to know the seed vigor is mostly used to just make decision about storage. How long can you store your seeds? So if you have different seeds with different qualities, you can say, I want to plant these or get rid of these seeds. So you can make all those decisions. And beneficiaries are mostly the seed banks and seed companies or anybody who stores seeds. And on seedling vigor, this is specifically helpful to growers mostly in horticulture. Most people they don't like doing corn like just throw seeds in the field. You sow your seeds and then you transplant. And so it is helpful to be able to tell which seedling has more potential to give you a good yield. So, but to know that, we need tests, and there are a lot of tests that have to be approved by international seed testing, but they are time-consuming. They are destructive. You need to understand a whole lot about lab work, and they are quite old. So now let's look at the new age. So as you all know, many things are going into automation. Image analysis has a lot more potential and can be used in a lot of applications. It's very quick and non-destructive, so you can analyze your seedling multiple times. You won't, since you won't need to destroy it. That's why we love image analysis. So the imaging system we are using, it's a Cultivars and imaging. And that's why when I said the seedling has to be able to perform photosynthesis, this is where it comes in. So we have our image system and LED blue lights. And we have the camera that has a special filter that will block the blue light. And we rely on the plant's ability to perform photosynthesis, and the light will cause the chlorophyll fluoresce, and that's what we will be able to see. So our camera will only be see a plant and not other objects. We can only see the things that can fluoresce. So we will do 3 studies. First, we will quantify germination rate in different lettuce cultivars. We will do some edging treatments, and then some gibberellic acid treatments, and I will explain those later. And so we chose lettuce because of its good growing habits. As you see in our camera, we take images from overhead, so we don't want to plant that will shoot through the camera. So lettuce is very helpful in that way. And short life cycle, so within 3 weeks we can finish a study and do more. So messing up is not it's a big deal, but not too much here. Our objective is to quantify the germination rate, the uniformity, and the seedling vigor using our imaging system, and also predict the seedling potential because seedling size can be used to predict the plant's potential to give us a good yield. So we are using 10 lettuce cultivars in the growth chamber, and we'll take images 3 times a week for about 2 weeks, until the transplanting time. That's where we stop our taking images. And so what we do, we take seeds, we germinate them in a growth chamber, we take images, that's all. But at the end, I will also explain how in the predictions, if we analyze our images, we make predictions of plants that will do well. So for us to see how accurate we can be, we'll have to grow plants to their maturity and do dry wet and see how good we did. And so we take our images we have a tent, and we close it, take images, and as I said, the images will only be plants, no background. The only things that can fluoresce, and so this shows you what belongs to that. All right, and we have to download the images. This is quite some work because I have to take a tray into the tent, close it, take a picture, very fun. No, not really. But to the fun part, then we use a Python based program, free, OpenCV, and it has been modified by a lot of people in our lab and other people. So let's see what we can do with it. And so we take our images we downloaded, we run through them, and we can do multiple files. So in this study, we had like 240 images. So you just specify your location, and the program will go and analyze all images by one click. How cool is that? And we get output images, and but we are interested in the Excel file that we get, and there are many things they can quantify, and Peyton talked about some of them, but we are interested in area. And originally it's a pixel number, but we can use calibration factor to transform it into something we understand in millimeter squared. And that was our one program. So now we have a new program. So currently we did them separately because they are different tools, and this tool can automatically do germination rate. So can't give me like actual numbers, and it can also go in the tray. So as you saw like it's a tray that we analyzed, and the previous program can do the total, the general total in the image. But this one will go in the image and analyze each plant individually, and you can do whatever you want with it if you want to track a specific plant, but not depending on your goals. And so we want to merge those tools, and by all that data, we have an Excel file, and we can analyze them. And so this graph just shows us the canopy size over time in different cultivars, so we can compare the germination rate in different, let us, cultivars. And potentially, we would like to be able to use this concept to also, monitor and understand the differences in different seed plots, which is actually more useful to seed storing people. All right, and so yeah, we were able to achieve our goals. We were able to quantify germination rate, automatically analyze a lot of images at the same time, and with an extra tool, analyze individual segments. All we need is to merge them up, hopefully. And so, as Peyton said, the plant captures light, and the more light the plant can capture, the more growth it gets. So from the canopy size, because based on that concept, we can predict the future plant growth. And so we can say this plant has potential, will give you a good yield. All right, and so after that, the second study, we are working with aging and storage. So as we've seen, this germination is affected by the metabolites in the seed, and inevitably over time, these will lose quality over time. But storage conditions will add as a factor, so it can even speed up the deterioration and losing the seed vigor. And so, with that concept in mind, we would like to do some edging treatments and quantify germination effect by edge on our seed germination and seedling vigor. And we will. There are multiple methods to do the test, but we will work with saturated accelerated edging because we're working with lettuce in a small seed. So this is a more appropriate method on small seeds. And so we will soak our seeds in salt, sodium chloride for different times, 2 days and 3 days at a high temperature to speed up the aging. And on control, we're still not sure which best way, either to do the traditional accelerated aging by just water or no treatment. And so, yeah, we'll see what works best. And after we treat the seeds, we will sow them and do the analysis just like the preliminary study. And so, the hormones. So it's been found that applying butyric acid on seeds can help improve the seed vigor, especially on seeds with less vigor. And we would like to apply the same concept. However, the butyric impact, in many literature reviews, it looks like it's not like a very exact. It can or cannot, depending on a number of things. But in our case, we will be dealing with new and old seeds, and we'll see if we can apply on the new and old seeds and see the impact the butyric acid can have on the germination rate. And this is because gibberellic acid, as we've seen, can break dormancy, but at a very early stage, it also helps the cell elongation. So that early boost in growth, we hope it would give us more potential. And so we will soak seeds in different gibberellic acid concentrations at 25 temperature for 2 and 3 days. So after that, we will sow seeds and take images as we did in the previous studies. And so how do we know if this worked? Well, first of all, if we are able to quantify the germination rate, the uniformity of germination, which is especially very important on commercial growers who sell plant stocks. And if we can quantify the seedling vigor, that's good. And lastly, our goal is not to just prove the concept that image analysis can work. We would also like to be able to apply this to commercial growers. And so if our methods are cheap, fast, and more accurate, that's how we can evaluate our work if it's been very successful. Also, and that's where I go to the next stage of potential collaborations. So the image system I showed you, it's a tent and a camera that is like 500 or about some thousands.
Everything is probably $800.
Okay, so yeah, and so to convince someone to apply on their greenhouse, it's less convincing. So we're trying to use the same concept, but use very cheap methods like Raspberry Pis, but I don't know how. And so Raspberry Pi. So it's a very it's a very cheap camera and already being used in many different ways. And so if we can you use our program into that computer and just do everything automatically and cheaply, we would love help on how to achieve that goal. And so we've done accelerated aging, but we would also love to do this on actual aged seeds. So maybe like a seed banks, or I don't know. Where we can see like seeds, let's say from year 1 to year 10, and just take images across and see what happens. And with that, we would also, as I said, would like to apply this to growers and see if our tools are relevant to the growers, which is our goal. And personally, I am from Rwanda, as Mark said. So I see many tools in our lab, technologies within the controlled environment, but most of the times they are not useful to growers in other countries. So I am I don't know how, and that's why I'm saying this. I'm very interested to see if there will be any collaborations where we can apply the tools to other countries and see what we can modify to accommodate other needs, not just what we already know in our labs. And with that, I really would love any guidance on next things, and that is all.
Questions or comments for Mark?
Great presentation, Mark. So you put some concept of uniformity in your presentation. I'm wondering how you're going to access the uniformity with your current imaging program.
Oh, okay. So when I do the plant CV and it can analyze when I have a tray and it can analyze each individual plant, we can see the differences if there are too much differences or less differences. So yeah, we
You mean the differences in
in, yes, yes, in differences in canopy size of the seedlings in that specific seed plant.
Do you have any other also plan for evaluating other perspectives rather than just the canopy size?
Currently, we just the canopy size.
So I guess you know one of the vegetable germplasm collection stations in Griffin, Georgia, right? And actually, interesting when you go there, there's a lady there, and all she does all the time is germination tests, and she loves it. You go there, it's the most excited people you've ever seen doing germination tests. But so they are at Griffin now, they don't work on lettuce. But if you're looking for somebody convenient to collaborate with, and I can give you the name of the curator.
Yeah, that'd be powerful.
They don't work on lettuce.
Yeah, we want to talk to them and then the Georgia Seed Development Commission as well. They also don't work on lettuce. Doesn't really matter.
Maybe you should go to corn. Okay. Yeah, thank you so much. That's very helpful. Yes.
Question, when you're looking at like seed vigor and things like that, is it really just like how many seeds germinated, or are you actually imaging the seed cells, like
Oh.
before germination?
So I used to say like seed or seedling.
Seed,
Okay, so the germination test is one of the ways to test the seed vigor. And so how fast and the uniformity, those are the parameters we're looking for. And so the more uniform, the faster we can get the germination, the first germination happening. That's how we can say this was a good seed. This was a little sleepy. Yeah.
that makes sense.
Thank you. Yes.
This might not be like specific to your projects, but in one of like the orchards I use for my research with apples, there's like this really cool like apple sorter that uses like cameras, and you can like choose different parameters and like how to sort the apples based on color or size or anything like that. Is there anything like that for seeds, like using cameras to test how the quality of seeds and being able to sort them somehow?
So on the one we're using, no, but so it sounds like what you're doing is based on the parameters of the color.
Yeah,
So-
or really you could choose very different.
All the side. So we're not. Yeah. It's the concept is the same. It's it's the computer visualization. As long as you are able to tell your computer how to know the color and what to do with it, so you can apply the same concept. So for us, we're just focusing on how big.
So in commercial greenhouses where they produce a lot of seedlings, what they typically do before they ship those seedlings to other greenhouses is that they do go through a sorting machine. It looks for empty spots in a tray. So a single tray might have 300 seedlings in it. And if there is an empty spot, then there is a robot that then can put a seedling in there. So that when I buy those seedlings and I get them, every single cell in that tray will have a seedling in it. Because obviously I'm unhappy if there is a whole bunch of them missing. So they have automated systems that can do that already.
Yeah.
Are very expensive.
Yeah, and also seed sorting. I mean, so for corn, if they do molecular markers, they have a machine that orientates your corn seed in a certain direction and make a little chip on the one side, test the DNA for that, and then extract that DNA sample at the corn seed. And then only plant the ones that they want. They're all automated. I mean, they're not doing that by hand.
Yeah, there's potential. Come to image taking, especially when I'm taking these images. It's fun.
Nothing online, someone has questions.
Oh yeah.
Anyone online has questions?
If not, any more questions in the room here?
So I just one question, your second objective where you're treating it with sodium fluoride. The whole, I'm still wondering, the objective of the study is to that sodium fluoride, you would see more aging, and so hence effective germination? Like, is that your hypothesis or?
No. So we so the what we're doing is the accelerated aging. And accelerated aging is to age seeds quicker, not waiting for 3 years, but in a few days. So the reason we chose the salt treatment, it's because the traditional accelerated aging, we use high temperature, high relative humidity, but the problem is on lettuce, because they're small seed, they will absorb too much water, and so if you have various sizes, you are not looking at just the age, also looking at the seed size. So that now there's too many variations. So the salt will reduce the moisture absorption, and that will control your aging, and it will be more accurate on your stage. So this is instead of traditional accelerated aging, all we do is add salt to reduce moisture absorption of the seeds.
If you're using imaging, can you image the seed before and after and compare seed sizes? Take into account that variable?
Yeah.
Maybe in a PhD.
That should be simple.
Yeah.
So, you're just minimizing water uptake, you said, for the seeds by adding salt.
Yeah. Yes.
So wouldn't salt too get in, like?
Okay.
I also know sometimes people use peg for that, because
Use what?
like peg to mimic like peg, because it's a bigger,
Polyethylene glycol.
Oh.
because it's a bigger molecule, it will not enter
Enter.
the seed.
Okay.
But this is a published method, not something we came up with.
Oh, okay.
Oh, yeah. Yeah, it's just advised. So
Yeah, just curious.
yeah, I understand. And taking images. Obviously, it sounds fun. And I didn't show it here, but I did a small study with the multi-structure imaging, and we would take images of seeds during germination in radical emergency during that early stage. Trouble was to keep the seed steady, to know where the seed was and to track that seed. So yeah, we can do that. It sounds very fun. Yeah.
Got one more question.
Yes.
With the Raspberry Pi camera, is it just like you wouldn't have to have a tent and you would just hold it over images, or how would that improve or like reduce costs?
Oh, yeah. So the first thing is it's very cheap. You can do that, do all that under $100 versus 800. That's the first concept. And also by Raspberry Pi, instead of always moving the trays, if you can be able to just mount the camera in the growth tent and just take images automatically, like over times day, every day at this time. So those are many ways to make our lives a lot more easier.
But these are actually cheap enough that we could put 30 of them inside of the growth chamber and monitor every tray of seedlings individually, automatically analyze everything automatically, because the Raspberry Pi, if you're not familiar with it, it's a computer, and a reasonably capable computer. So not only does it take pictures, it can do all of the image analysis and then load it to the cloud somewhere.
Oh yeah, so yeah, in that then I won't have to take image, download online. You just sleep. Online.
Hi, Mark. Hey, this is Jordan. Can you hear me okay?
Yes.
Hey, I had a quick question. Great presentation. Have you thought about using like a handheld LiDAR or any other kind of like compound imaging to generate 3D models of the lettuce seedlings that you're looking at?
Not really, but with plant CV, amongst other parameters, we've been able to see that they give us the length and the width, and we can use that to do anything. But currently, no, we're just interested in the canopy area of the seedling. But yeah, that's
Okay. Okay, cool. Yeah, I was just wondering how SSAA could affect like the morphology of the seedlings as they grow or like as they age by looking at 3D models of it. But I think you can get a lot from just like looking at the 2D images as well. I was just curious.
Yeah, it's possible, and actually sounds a lot more interesting.
So, yeah, and LiDAR would be really interesting, but you cannot do it for really cheap. So, and we want to develop something where we can really bring the cost down to almost nothing.
Yeah, that's a good point. Or the handheld LiDARs, they're really cool, but yeah, they're expensive.
Well,
Thank you.
Now, right? I mean, iPhone basically has a LiDAR built in, right, Chanjan? It's really bad picture.
Awesome, thank you.
Yeah, and with that, we're not working on that specifically, but we hope that maybe in the future we can find someone in computer programming stuff and maybe do the same concept and maybe have a phone app. So that's all in hopes. What I'm capable to do is all this.
So do you think there's any way to do it non-destructive? But that's really the gold standard, is to really determine germination rate without doing germination, right? So there's some, staining methods, but that's still destructive. So I was wondering whether you have any thoughts on, not really with this system, but I mean, just thoughts in general about that.
Yeah. There's a tetrasonium, which we're not interested in that. Yeah, but that would be interesting. There's one something like that, where they can actually look at the morphology of the seed with our image, and yeah, they are capable. Yeah, they can do it, but it's mostly based on the seed size and the shape they're looking for, and they can determine the morphological characteristic of the seed. But it's still an exploration. Yeah, many things are possible.
I wonder if your X-ray kind of. You beat me by 10 seconds. Darn it.
Well, we have access to the CT scanner.
We do. All right. Well, and it sounds like then I have to do my PhD here. Yeah, I think it's time.
Well, you're eager to leave.
No, it's fun.
Well, thank you, Mark.
Thank you so much.
Nice job.